Hey everyone, welcome back. Today is the day 4 of our vector database 0 to hero series. In this video, we will understand what embedding models are and why they are so important. We'll also explore the power of vector math in embeddings with some visualizations. And then we will also explore the different types of embedding models that we have out there. And then finally, we will look at some popular embedding models used in production systems today, right? So by the end of this lecture, you will have a solid understanding about embedding. So without wasting any time, let's dive in. In the last lecture, we talked about tokens and we understood some important concept about tokens. So tokens are nothing but converting this raw text into this numerical representation. And why we convert raw text into numerical representation is because your embedding models, they don't understand text, they only understand numbers. But the key thing that you have to keep in mind is that these numbers are just numerical representation of the raw data. These numbers, they don't carry any semantic meaning. These are just some symbols. This is not the meaning of the raw text. But then when it comes to vector databases are all about semantic search. So here at this point, a very important question comes up. If tokens are just some numerical representation of the raw data and it doesn't carry meaning, where does the meaning then come from? So that's exactly the problem that the embedding model solves. So let's try to now understand how the embedding models solve that problem. So what happens is, first, the raw data is tokenized and converted into some numerical representation, and then these tokens are given as an input to this embedding model. And then the embedding model takes these tokens and converts into vector embeddings. And these vector embeddings is what capture the semantic meaning. And as you understand, these are just nothing but some vectors in the vector space. And let's say this vector space is about 1000 dimensions. So this embedding model would then generate vector embeddings of 1000 dimensions. So you would have around 1000 numbers in this array, and these numbers are nothing but it just denotes some coordinates in the vector space. So that's what is the vector embedding. It's just some coordinates in the vector space based on the dimensions. So the core idea here is very simple. So the items or the text that has similar meaning would be closer together in the vector space, whereas the items that has different meaning would be further apart in the vector space. And since these embeddings are nothing but vectors, we can actually perform some vector calculation on these embeddings. So now to demonstrate that, let me show you some interesting examples with some visualizations. Okay, so now I am in this vector playground and the model that I'm using is the Globe 300D. Now, since these embeddings are just mathematical vectors, we can actually do math based on these vectors. For example, let's say if I were to perform this vector calculation, king minus men plus women, and try to calculate, you can see that it relates to queen. So though we never train this model, the relationships between these words are calculated based on the vector calculation. And this is very powerful. Let's take another example here. Let's say we do Delhi minus India plus Japan. And if you try to calculate that, it leads to Tokyo. So Delhi is the capital of India and Tokyo is the capital of Japan. Now, these calculations based on the vectors is very interesting because all we had to do was convert these words into vector embeddings in this vector space, and then we can perform this vector calculation. And this is exactly the concept behind semantic search, because what happens is that all the words, when they are converted into vector embeddings in the vector space, the words with similar meaning would be closer together in the vector space, whereas the words with different meaning would be further apart, and that is the basis on which we can perform vector calculation, and this is the fundamental concept that powers your vector databases. So you can perform similarity search based on these vector calculations. Okay, so just to summarize, the embeddings are nothing but just the coordinates in the vector space. Here we are plotting these words in the three-dimensional vector space, but then when we work with the real embedding models, those vector spaces tend to be higher dimensions, and all the latest embedding models, they even generate vector embeddings with almost 3000 dimensions. And that is why vector databases are heavily used in building the semantic search in the modern applications. Okay, so now let's look at the types of embedding models that we have out there. So the first type we have is, it all started with the word embeddings. So the first type is word embedding models. So what this word embedding model do is, it takes a piece of word as the input to the word embedding model. So it takes the word as the input, and the output is nothing but some embeddings, some floating point numbers. Okay, so this is what the word embeddings would do. Now, some popular examples of the word embedding models are, you have the word to vec, and then another example I can think of is globe. So these are the two popular word embedding models that we have. But the problem with word embeddings is, let's say you are trying to do embedding for the word river, and then there's another word, let's say bank, and there's another word, let's say account. Okay, so what happens in word embeddings is that the embeddings are generated for individual words. So the thing is that the main limitation is that, let's say you have a sentence river, let's say you have a sentence river bank, and you have another sentence bank account. Now, since these embeddings are generated for individual words, the thing is, we would not know what bank actually refers to in the sentence. So the main drawback of word embedding is that the context is missing in word embeddings. So that's the main limitation of word embedding models, but that is how we started. We kind of developed this word to vec and globe embedding models, which are powerful if you want to do, individual word search, but then it's not powerful when you try to find the context of that word in a given sentence. And that's the main limitation of the word embedding model. So that's the first embedding model that we have. Now, the second type of embedding model that we have is the text embedding models. This is the second type of embedding model that we have. Now, in this, as you might have guessed, here, this text embedding models, what it does is that it takes sentences, or you can even take paragraph, or the entire document can be sent to this embedding models as an input. And what it does is that it converts this sentences, paragraph, entire document into vector embeddings. So what happens is that this type of embedding models, the main advantage is that since we can embed the entire sentence, the entire paragraph, or the entire document, so based on that, you would have the embeddings generated, which means you can compare two sentences with each other. You can compare two paragraphs. You can even compare the entire document with, a search query. So that's the main power of this text embeddings. And nowadays there are many text embedding models. You have it from OpenAI, you have it from Gemini, and almost every providers out there, they have some sort of text embedding models, because that's kind of the foundation on top of which the LLMs are built. So yeah, so this is what is the text embedding models, and this is heavily used in semantic search. It is heavily used in building RAG systems and recommendation engines. So that's the text embedding model. And the third type that we have, and this is very popular nowadays, is the multimodal embeddings. Yeah, so this is the third type of embedding model, multimodal embedding. Now, what this multimodal embeddings do is that here, along with this sentence, paragraph, and entire document, you can also, generate embeddings for images. So you can also send images. So basically, this multimodal embedding, they support text plus images, and that gets converted into vector embeddings. So these are the three popular embedding model types that you would come across. Now, nobody uses word embeddings because this was just the inception of embedding models, but this kind of led into several more researches, and then the outcome was we came up with text embedding models, multimodal embedding models. But then nowadays, mostly you would be using text embedding models and multimodal embedding models in your vector database pipeline to kind of build semantic search. So if you are, let's say, building something that's purely based on text, there's no point in using multimodal embeddings. You can just build that use case using text embeddings. Whereas, let's say you kind of want to support a RAG pipeline or a document search, you want to build that on some sort of, let's say, PDF, and the PDF contains both text and images, then obviously you would go for multimodal embeddings. So that's the main power of multimodal embeddings. So these are basically the three types of embedding models that you would come across. Okay, so now here are a few popular embedding models that you should be aware of if you're building semantic search and RAG pipelines using vector databases. You have this text embedding models from OpenAI. You have from Google Gemini Embedding 1. Then you have other embedding models from Cohere, and you have it from Microsoft Codebird, which is optimized for understanding code. And then recently Google released this Gemini Embedding 2, which is a multimodal embedding models. And here you can see all the list of dimensions that they support. And here are the use cases. Mostly you can see the use cases are for building RAG and semantic search. Codebird is used for, finding code similarity and code search. Whereas this is Gemini Embedding 2, which is a multimodal embedding models, and that supports both image and text search. Now, don't assume these are the only embedding models out there. There are many more, but I just wanted to highlight here few popular embedding models out there at the moment. So the key takeaway from this video is that tokenization just converts raw text into numerical representation, which is then sent to the embedding model, which generates the vector embeddings so that you can perform some similarity search and build RAG pipelines and recommendation systems. So that's all in this video. Hope this video was useful, and see you in the next one. Thanks for watching.